In this video I'm going to look at acyl or acid chlorides. So we'll start with just saying what is an acyl group, and it's drawn up on the board there. The general formula is R, so that's any carbon group, C double bond O. So an acyl chloride is just R, C double bond O with a Cl also attached to that carbon. So before we go into looking at how they're actually formed, we're going to look at how you name acyl or acid chlorides. And before I show you any examples, just want to say that their names end Oil chloride. So the formulae on the board there and the Molly model all represent ethanoyl chloride. So you can see we've got two carbons, so that's the eth part, and there's that ending oil chloride. So putting it together, ethanoyl chloride. So we'll just do a quick naming exercise now. There's 4 acyl chlorides on the screen. If you want to have a go at naming them, pause the video and then I'll go through the names. So you can see the first one there has 3 carbons, so that's just called propanoyl chloride. The second one is the acyl chloride of benzene, and so we call that benzoyl chloride. You can see there the third one is called 3-hydroxy butanoyl chloride. I'll just explain why. So carbon number 1 is determined by the acyl chloride group, the COCl group. So that's carbon number 1, which makes the third carbon along is the one with the OH group on. So because this is effectively an acyl chloride, we have to call that OH group a hydroxy group, and so we say 3-hydroxy butanoyl chloride. And there's the name for the last one, 3-hydroxy 2-methyl butanoyl chloride. So again, carbon number 1 is the one with the COCl group on. So you can see the other numbers of the carbons there. We've got a methyl group on carbon number 2, and we've got an OH group, a hydroxy group, on carbon number 3. You can see I've underlined the H and the M of the hydroxy and methyl groups because we've got to bring the alphabet rule into play now. So H comes before M in the alphabet, so that's why we have to say 3-hydroxy before 2-methyl. We'll just finish this introductory video by looking at how you actually make acyl chlorides. So you make acyl chlorides by reacting a chemical called thionyl chloride, that's SOCl2, with carboxylic acids. So below I've got the general equation there for making an acyl chloride. RCOOH, that's obviously the carboxylic acid, reacting with SOCl2 to make RCOCl, that's your acyl chloride, and you also make SO2, sulfur dioxide, and hydrogen chloride, HCl. And you can see I've written up an essential condition for this reaction is that it must be carried out under anhydrous conditions. So you can't have any water present. Otherwise your acyl chloride will react or will be hydrolyzed by the water and form a carboxylic acid. So if that was the case, you'd end up back where you started. So we'll just finish with a specific example just to check you've got all of that, which I'm sure you have. Question is, how would you make CH3COCl ethanoyl chloride? And of course you'd use ethanoic acid and you'd react that in anhydrous conditions with thionyl chloride, SOCl2. And there's the equation there as well.